In this video I'll be talking a bit more about object visibility. Let's have a look again at M31. Let's say we want to know when this object rises on the night sky and when it sets on the night sky. And we also know how much space it will take up when we take an image of this object. What is the field of view as it appears in an image? We have a couple of options on in Stellarium actually where we can decipher this. We have to go into the configuration window, open this secret bar again over here, click on configuration window, click on plugins, and install the observability analysis plugin, load at startup. And also install the Oculus plugin, load at startup. And then you need to restart the program. Basically just quit it and open it again. And you need to reset the time, February 21st, and it was in the evening. Boom, boom, boom. Now you will notice that you have an extra bar over here. And you also have an extra option down here. Let's take a look at what this does. M31. If you click on this little image down here, you'll get some information on the observability. So what this tells you is basically some details on when this object rises and when it sets. And for this particular object, there's actually no cosmical rise or set. This object is always visible from this location. The only thing that changes is basically how high it appears in the night sky. So that's really nice for M31. But we also want to know a little bit more about how much space it takes up on an image. And for that particular question, I recommend that you open this little menu bar over here, the configuration tab. And then you click on sensors, and I've already input the sensor detail for the sensor in our telescope here at Brofelde. It's an SBIC STXL 16200. All the details can be found on SBIC's website. It's a 4500 pixel by 3600 pixel CCD. There's some details on how wide the chip is and what the pixel width is. All these details are required in order to simulate how much space it takes up on the final image. In addition to that, you need to fill in some details on the telescope, and I already filled in some details on our Schmidt telescope here at Brofelde. I just named it Schmidt main telescope, and it has a focal length of 1502 millimeters and an opening diameter of about 500 millimeters. You don't really need to fill in these details about the horizontal flip, vertical flip, because the program, when you want to see how it appears as an image, it doesn't really simulate that in this program. However, I did click the equatorial mount because it's an equatorial mount system that we have here at Brofelde. So let's see what this does. I've set up our telescope, I've set up our sensor, I can close the configuration tab, and now I can simulate how it appears as an image. Just click the image sensor frame, and boom. This is actually, the red line here indicates how much of the Andromeda galaxy you will actually have when you take an image of the Andromeda galaxy. As you'll notice, you won't actually get the entire Andromeda galaxy. The Andromeda galaxy takes up, I think, roughly about 3 degrees in the night sky, and our sensor here at Brofelde, it can only record approximately 1 degree across the night sky. So if you want to take images of M31, now you have learned that you need to take multiple images, and then you will actually need to stack those images or combine them in the end, and that's a completely different topic. Maybe we'll get to that in a later video.